So let's say you have a couple of services such as these. How do you make them testable? Let's find out. Hello everyone. Let's fix some code. So right here we have this very simple application. You can pretend that this is a controller or any entry point into your application. And what it does, it just prints out a couple of lines, calls a couple of service methods, and prints out its results. So if we run the application, you can see that it will return some of those lines here. So here it prints out some of those lines with the results. It doesn't really matter what those results are because we are going to write some tests for this. So let's see what actually these methods do. Let's start with the simplest one. So that is the multiplication service and its method multiply user income for no reason. All right, so let's see. It injects the calculation service. That means an external dependency. And then it has only a single method which returns a big decimal, but it calls that dependency. So how does one write a test for this? Let's do Command N and let's generate a new test, multiplication service test. And yes, let's write a test from Jupyter API, void, and let's see what it does. Multiply user income for no reason, and test calculation. Let's temporarily call it test calculation. If we figure out a better name, we can always change it. Don't be afraid to change variable names and function names and whatnot. So let's see. Let's try and get this multiplication service initialized. Oh, it needs a calculation service. Okay, let's try to initialize a calculation service. And this one needs some repositories, income repository, purchase repository, and calculation piece repository. Now, a lot of tutorials will teach you to go and get Mockito here and mock those repositories. Let's not do that. Let's actually mock the calculation service itself, but using what Java already provides us. And that is, we're going to extract an interface out of that one. All right, so if we go into the multiplication service, we can see that it uses a calculation service. And the calculation service itself is quite big. It has a couple of repositories injected. It has a lot of different methods here. How do we mock this? Well, the easiest way is to introduce a functional interface instead of a full injection. So instead of injecting the full calculation service, let's just inject one interface which has one method, and that will be very easy to mock in tests. Let's do it right now. The first important step is to actually find out what method is being called from the full service, and that one is calculate user sum. So our interface could be called just user sum calculator. Let's do it right now. Let's create a new interface and let's call it user sum calculator. What does the original method return? It returns a big decimal, so our method could also return a big decimal. And let's call this the same as calculate user sum. And it takes a single parameter of user ID. And that is our interface. Now, we can implement this interface into the calculation service. Let's make calculation service implement user sum calculator. Let's not forget an override here, so people know that this comes from some sort of an interface. And now in our multiplication service, where is it? Here we go. Now here, instead of injecting calculation service, let's just change this to user sum calculator, which is our interface that we just made. And let's rename this into user sum calculator. And that's it. Now it should be very easy to write the test. Let's try it now. Let's move this aside and let's open multiplication service test. So remember when we wanted to do new calculation service, we no longer need to do that. What we can do is we can actually make a interface. Let's try it the old way, and then I'm going to show you the Lambda way, or functional interface way. So back in the day, you used to write it like this. User sum calculator, let's call it calc, let's say new user sum calculator. And this right here is an anonymous interface implementation. Calculate user sum, let's say 32. Oh, that's a big decimal, so let's do a big decimal 32. And we could do it like this. And that would actually work. Multiply user income for no reason, user ID 1, not that it matters in this case, and then times, let's say 3 times. And let's assert the result. It should be big decimal 32 times 3, and that is 96. And let's put the result here. So if we launch this service now, everything should run fine. And as you can see, the tests run just fine. So let's make this a little bit shorter now. You can see that here it says anonymous new function can be replaced with Lambda. So if you just go and Alt Enter on this, this becomes a Lambda. And since this assignment is useless at the moment, this Lambda can be moved into a parameter of the constructor. And that's how you introduce an interface into your service so that it can be split out and tested easily. All right, let's move on to a more complicated service. Right in front of me, I have a calculation service, which has quite a few methods. So how would one go about writing a test for this abomination? Let's try it out. Let's make a new test. Calculation service test. What is our first method? Calculate user sum, just like we did before. All right, let's test for calculates user sum correctly. It's going to be our test name. And now let's see what this service calls. Now, anytime you need to look inside a service itself to write a test for it, that is not a good service, because you should only care about input and output and not what methods are called inside of the service. But just for the sake of this video, let's say that you're not able to do that for some reason. All right, let's analyze the calculation service. So what happens here? If user has any incomes, we return the sum of calculation pieces, and in other case, we just return an average calculated amount. Why do we do that? Nobody knows. That's what the business ordered. So the first thing that catches my eye is that we are actually interacting with 2 dependencies, but we are injecting 3 dependencies into the service. So this is a good signal that your service is actually a little bit too big and needs to be split out into smaller services. So let's first split it out and see how it can be tested then. So previously we have already extracted a user sum calculator interface. So we need some sort of an implementation for this one. And a lot of times you will see that it is actually done by calling it something like user sum calculator impl. And I'm not a really big fan of using impl classes. I would much rather call them something more precise, but you might encounter this in real life, and as a working title, it will be fine for now. So let's say user sum calculator impl implements user sum calculator, and let's implement the actual method, which has the same signature as this one. And let's just cut the code from there and let's paste it into our new service. And immediately we see that we are missing income repository and calculation piece repository. So we can copy those from the previous service. And this, of course, requires the class to be marked as a service and as required args constructor. So this is gonna take care of the injections for you. Now, just to keep the old code running, let's call our new service from the old service. And in order for us to do that, we need to inject our new service calculation sum, user sum calculator. And here's the trick. Don't inject impl, but inject the interface, and Spring is going to take care of it for you. User sum calculator, and right here we're gonna return user sum calculator, calculate user sum, pass in user ID. And if I try and launch our application, and here is where we encounter a problem, because user sum calculator is implemented in two classes. One is calculation service, and the other one is the new service that we've made. So let's remove implementation from calculation service. Let's remove this override. And now it should understand that there's only a single implementation of that interface. And as you can see, it works just as it did before. Now, some of you might say, oh no, we've made this class even more complex because we've introduced another injection. And yes, but this is actually a very necessary intermediate step so that you don't break your old code. Always try to keep your code compiling and running, because that is when you can have very fast iterations. You change a line, you run it. If it runs, great. If it doesn't, then you can take care of the problem immediately. Okay, so we should try and write a test for our new calculate user sum service. And if we do that, we're gonna encounter actually the same problem that we've encountered before. And that is going to be that we will need to mock some repositories. So let's use the skills that we have learned before to introduce an interface instead of a full repository. And let me show you what I mean by that. Let's put user sum calculator on the side just so that we know what we're dealing with. And let's try to make a test for calculates user sum correctly. Let's try and instantiate the service. Yeah, user sum calculator impl. And this requires two repositories. If we try to implement the repository, here's what's going to happen. We're going to get a lot of unimplemented methods, and there's just no way that anybody's going to go and try and implement those one by one. So the solution here is to introduce another interface, and you can do it in the repository package, or you can do it somewhere else. It's up to you. I'm going to do it in the repository. So what this service actually uses, it uses income repository exists by user ID. So we can call our interface, let's say, what can we call it? Income existence, is it with an E or an A? Existence checker. So this is our existence checker. And what we are trying to do is we are trying to have it define this method. And now our interface, with the addition of extending a JPA repository, it can also extend income existence checker. And since both of them are interfaces, this actually needs to be extend instead of implements, as with class. And also don't forget an override, so that people know that this comes from another interface. All right, not much has changed yet, but now let's make our service user some calculator, which was not here, but actually here. Let me drag this out for you here. Let's make this service inject our new interface instead of a full repository. Let's make this income existence checker, and let's call this income existence checker. And right now, if we navigate to our test, we can actually inject a lambda in here. So in this case, let's say users, let's say the income is going to exist. So this will return true. And now with our second argument, which is also a repository, let's just do exactly the same thing that we did with our other repository. So let's go and see what user sum calculator uses from this one. And now it uses two methods from calculation piece repository. So let's see how can we go about that. All right, let's put this on the site just so that we know what we're dealing with. And let's create a new interface. And let's call this, there's actually two ways of going about this. You can implement those two methods into one interface, or you could implement them into different interfaces. Let's first try and implement that into a single interface, and let's call that, it's going to be difficult. Let's call this, all right, let's call this service piece finder. That might not be the best name for it, but we will refactor that as we find better names for it. So piece finder, what does that define? It should define find by user ID, just as in repository. And it should also define calculate average amount. Now let's make our repository extend this piece finder. Let's not forget our overrides. And now in our user sum calculation impl service, there we go. Instead of injecting a full repository, we just do inject a piece finder, and let's rename it into piece finder. Nothing is complaining except for the tests. And right here, we can no longer inject a lambda, but what we can do is we can do a new piece finder and then define what it actually returns. But this is not very readable. So what I would suggest is to introduce a private class just for this one test. Let's do it right now. let's do a private static class. And let's call this piece finder impl. And here in the tests, I have nothing against the impl naming because it is only used in this single class. So what does it implement? It implements a piece finder. Let's implement those methods and actually delete what we had above. Now you can see that this implementation returns nulls. So we need to pass them in through constructor so that a known state of this object is created. Let's do a private final list of calculation piece entities. And let's call this calculation pieces. Let's do another one for the average amount. And it's going to be big decimal average amount. And let's make these methods return what they need to. Now what is missing is a constructor. So let's generate that. And now this class can be instantiated in our test method. So let's do a piece finder, new piece finder implementation. And right now its constructor requires two arguments, a list and an average amount. So let's try and pass a empty list, and the average amount is going to be 1, 2, 3. And in our instantiation of the service, we're gonna do a piece finder. And now this service can be called. So let's do a service, calculate user sum. It doesn't really matter what we pass here because those values are faked. Let's assign it to a result and let's see what we can expect. All right, let's check our original service implementation to see what is going to happen. And we've passed that income exists, so it should return a sum of calculation piece entities. We should make some of those. So let's do a private calculation piece entity. And let's call this method piece with, let's say, integer amount. Let's make this a little bit simpler for us. So let's instantiate calculation piece entity. Let's set its user ID to 1 because that doesn't matter in this case. And let's set amount to big decimal value of amount. And let's return the entity itself. So this is just a convenience method that allows us to very easily create different pieces of calculation pieces. So let's put some pieces inside of that list. Let's say this one's going to have 20. This piece is going to be 40. And this piece is going to be 60. What is the sum of that? The sum of that is 120. So let's assert equals for a big decimal of 120. And let's pass in a result. And we can see that the test passed. However, not all the permutations of this method are tested, because what will happen if income does not exist? Then it should return an average amount. So let's make another test case for that. And let's see, test. How are we going to call this? Let's call this something that actually conveys the meaning of what's happening inside of this test. And let's say returns average amount when no incomes are found. And that is a big test name, but we don't have anything against big test names because that describes exactly what it's testing for. So let's copy the code from above. And this time, let's switch this lambda to false because, as you remember, this was our income existence checker, and this says that income does not exist. So it should return a, well, let's make it interesting, and let's say this one is going to be 666, and it should return a 666 because this one was the average amount. Let's try and run the test again. And we see that another case also passes. Now let's just go ahead and rename our previous method and returns sum of returns the sum of calculation pieces when incomes exist. And to make this even more readable, we can put a display name for this test. Let's just make it something human readable. Return sum of calculations when incomes exist. And here we're gonna make a display name of return average amount when no incomes are found. Let's run the tests again. And we see that right now we have some nice names here. All right, and now the only thing left to do is to go to the original incorrect calculation service, find the usages for calculate user sum, and we can see that it is actually called from two places in split application. What we can do is we can delete those two. We can see what fails, and instead of having a God calculation service, let's inject our user, let's inject our, what did we call it? We called it user sum calculator. User sum calculator. And here it's going to be called user sum calculator. And here it's going to be called user sum calculator. And that is how you split services using interfaces. If you found this video useful, please leave a like. If you have any questions, please leave a comment. If you know any people who might find this useful, don't forget to share it. And if you have any suggestions on what I should show next, also leave a comment. But until then, see you in the next video.